As Lucinda said, the Mars Society was founded 20 years ago, and 1998. And shortly before it was founded, a few years before it was founded, there was a book published that was a bestseller. It was called The End of History. It said, we've reached the end of history, had a nice run, 3,000 years, but now everything significant that is going to happen has been done. Sorry, we missed the bus.
Oh.
And then actually shortly before the conference was held, there was another book published, which was also a bestseller. It was by the editor of Scientific American, James Horgan, who said the end of science, that we reached the end of science. Everything that could be discovered has been discovered. It's been fun. Sorry, you missed your chance to contribute. But there it is. I believe that these books could not have been more wrong. That the opposite is true. That we are not living at the end of science. We are living at the beginning of science.
Yes.
And we are not living at the end of history. We are living at the beginning of history. And, now part of the disproof to this has been rendered by NASA and the other space agencies. There are certain flaws with some of the things they're doing, but the one parts of these agencies that have really delivered has been the science programs, the space astronomy and planetary exploration programs. Shortly after Horgan published his End of Science tract, researchers using the Hubble Space Telescope reported finding that the rate of expansion of the universe was accelerating, which is impossible according to the four laws of science that were known in the laws of physics that were known in the first part of the 1990s. It would have to be decelerating. The question is, would it be decelerating enough to stop or not? But no, it was accelerating, which means there's a fifth force in nature, counter-gravity, which, means, there's more things on heaven and earth than are dreamed of in your philosophy, Horgan. And then there's been other discoveries. Of course, in the past few years, we've had the raft of discoveries of Kepler, perhaps the most cost-effective science mission in history. The discovering thousands of extrasolar planets of every description, Earth-like worlds, super Jupiters, hot Jupiters, water worlds, diamond worlds. The multitudes are incredible, and it's now apparent that planets around stars are rather the rule than the exception. We are living in a universe of trillions of worlds, and probably trillions of communities of life. And then in particular, just this year, just a few weeks ago, starting in the 90s, a discovery of water, traces of water hinted at by Clementine, but then confirmed by subsequent probes, and then just this past week, today, in fact, I saw a paper on water ice on the moon, but even more exciting than that, a liquid water lake underground on Mars, which is definitely a habitable environment. So if you're looking for life on Mars, you want to find not just fossils, but extant life, go there and drill. And then I've seen data, and you're going to get a presentation on this tonight. We scheduled this, which schedule was changed to invite a presentation by one of the scientists involved. And he's going to be more conservative than me, because scientists like to be conservative. They don't want to claim more than they've really found. But I've seen the data, and let me tell you what they found. They have found glaciers on Mars, in mid-latitudes. And these are made of pure or nearly pure water ice. And the amount of water in these ice formations is substantial. Estimates run to 3 million cubic kilometers.
Wow.
Not cubic meters, cubic kilometers, covered by only a few meters of dust. In other words, this is not deep underground. This is something you could reach with a shovel. And this stuff, 3 million, you know what 3 million cubic kilometers? The entire Earth's fresh water supply is 30 million cubic kilometers. This is 10% of the world's fresh water supply is available in ice or nearly pure ice on Mars, near the surface, at mid-latitudes, not just at the poles. Okay, this is incredible in terms of what it means for resources, for Mars exploration. Okay, underground water, surface ice, okay, carbon dioxide atmosphere, carbon dioxide water, you've got the stuff you need for propellant, you got the stuff you need for life. Okay, water on the moon is good, although if you want to use it, you have to actually go to the moon, not to lunar orbit. Okay, that's an important point. We've yet to find substantial supplies of carbon on the moon, and that's important because we're carbon-based life forms. We are made of carbon. Everything we eat is made of carbon. Everything we wear is made of carbon. Everything we use is either made of carbon or made using carbon. So the water on the moon does definitely enhance our capabilities for exploring the moon, but if you want to settle in a world with carbon, Mars. And there it is. So, and by the way, let me tell you something, because there was another paper published a few weeks ago that made some headlines. In the 1990s, a very widely read paper was published saying that there could not be water ice on Mars at mid-latitudes. The author was a man named Bruce Jakowski. He's the person who published the paper a few weeks ago saying there is enough CO2 on Mars to terraform it. And that paper is not scientifically sound, because all the MAVEN does is measure the amount of CO2 that Mars has lost, which he says, according to his measurements, which some people dispute, but I'll give him, because he's arguing from his data, he's lost half a bar in its history, but that doesn't tell you how much is left. And in fact, we know, because of the water erosion features on the surface of Mars, that Mars once had at least 2 bars of CO2 in its atmosphere. So far from there not being enough CO2 on Mars to terraform it, the MAVEN result supports the theory very much so that there is enough CO2 on Mars to terraform it, as far as that goes. But that's another story. We'll discuss that. But okay, so in the areas of space astronomy and planetary exploration, the official space programs have truly delivered. Okay, in the human spaceflight area, they've been adrift for 40 years. And they continue to be adrift, and in fact, at this point, it's reached the point of satire. But I wouldn't say it's okay, but there's been a solution. Because every problem creates a solution. Every problem creates a necessity for another invention, and it has given birth, and to quite the child, SpaceX.
Right.
Okay, we have a revolution going on right now in spaceflight. An extraordinary revolution. This is something that, people talked about. Musk is actually a science fiction character. He's in the novel Firestar, for example, by Michael Flynn, except there the Musk is a woman. This D.B. Harriman, Heinlein had him decades ago. But he finally appeared out of the world of fiction into the world of reality. And look, February this year, Falcon Heavy launched. I think almost everyone here saw that. And
Bravo.
And this was a tour de force. Not only, look, in 2009, the Obama administration wanted to kill the Bush moon program, so they pulled together a blue ribbon committee headed by Norm Augustine, the CEO of Lockheed Martin, and they concluded that the Bush moon program was financially impossible because it needed a heavy lift launch vehicle, and developing one would take 12 years and $36 billion. Okay, Musk did it in a 6-year program for less than $1 billion. Half the time, 1/30th the cost of what had been projected. And not only that, the thing is 3/4 reusable.
Right. Yes.
So that's a shot heard around the world. And now, of course, they're proceeding with the BFR, which we'll talk about in a minute, which will be even much more capable. But the significant thing about Musk, even if Musk was to fail at this point, he has already succeeded. because he has demonstrated that it is possible for a private entrepreneurial team, well led, to do things that previously had been thought that only governments of major powers can do. And so he has set off the gold rush. There are going to be more SpaceXs. There's already a couple more in the United States that are competing with them. Blue Origin, most notably, Stratolaunch, Virgin Galactic, but there will be a Russian SpaceX. I happen to know there are people there that want to do it. There's a Ukrainian SpaceX emerging. There's going to be Chinese SpaceXs, you can bet on that. Okay, Indian. Okay, people are going to want to do this, and they're doing it. And by the way, not only in this sphere, okay, there are now fusion SpaceXs. You know, I worked a little bit in the fusion program in the 1980s, and I can remember we had a lunch, and the group leader said to us, you know, when fusion is finally developed, it's not going to be developed at a place like Los Alamos or Livermore. It's going to be developed by a crackpot working in his garage. Okay, well, probably not a crackpot in a garage, but a startup in a warehouse, yes.
Yes.
Okay, and some of these startups have now gotten hundreds of millions of dollars of money to pursue new approaches to fusion that are outside of the mainstream, which is real narrow to a single international tokamak, which, with all the bureaucracy that implies and the limited innovation that implies. So this is happening. So creative forces have been unleashed as a result of that. And it's now clear, okay, how we can get to Mars. Now, you know, I'm an engineer, and so for the past 30 years, I have been advocating a clean engineering approach for getting to Mars, known as Mars Direct. You know, you can do it with 2 heavy lift launches. The first launch shoots off to Mars, the Earth return vehicle with no one in it, runs a pump, sucks in the Martian air, reacts it with hydrogen. Martian air is carbon dioxide. You make methane and oxygen propellant. Now you've got a fully fueled Earth return vehicle sitting on the surface of Mars. Once that's done, you use the other launcher. You send a habitat module out to Mars, something about the size of the MDRS station, which, by the way, was designed specifically to make it flight-like. In this respect, 8 meters in diameter, launchable. Boom, you send that to Mars. Crew flies out to Mars and that. You land on Mars and that. That's their habitat on Mars. That's their lab on Mars. After a year and a half exploring, they get in the Earth return vehicle, fly home. They leave the habitat behind on Mars. Each time you do this, you add another habitat to the base. Before you know, you got the beginning of a new world. This is the basic plan, Mars Direct. Direct to Mars, direct back from the surface using locally produced propellant. Okay? You don't have to build gigantic interplanetary spaceships based in lunar orbiting space stations and all this kind of stuff. Okay? Okay, so Musk has picked up on that. He's developed his own design. Initially, it was quite grandiose. The ITS, 500 tons to orbit, 500 tons to Mars. They moderated that to be more realistic, 150 tons to orbit, fully reusable, and then he wants to send it all the way to Mars and back. Now, I wouldn't use it that way. I would just lift 150 tons to orbit and then shoot the payload to Mars from there, and that's a fully reusable heavy lift vehicle. You can do Mars Direct with that. There it is. With the launcher fully reusable. If you want to deliver over 100 tons to Mars with a throw, you can refuel the BFR and bring it up to, so it then goes from low Earth orbit to a translunar injection type orbit, which is to say an elliptical orbit just short of Earth escape, and then release the payload, and with a very small push, the payload flies off to Mars. The BFR is back in low Earth orbit a week after it left, and you can reuse it 10 times during a launch window instead of once every other launch window, which is what you'd have to do if you sent it all the way to Mars and back. But they're catching on to that. So anyway, the point is they've got the machine. And not only that, the thing that BFR is very well designed for is point-to-point intercontinental travel on Earth. Okay? And if you think about it, if you want to have the real space revolution, or reduce the cost of launching to orbit by not a factor of 5, which is what SpaceX has already accomplished. They have. Okay? Or 6. I mean, Falcon Heavy is twice the payload of an Atlas at 1/3 the cost. That's a factor of 6. Twice the payload of a Delta IV Heavy at a third the cost. Three times the Atlas, 1/2 the cost, twice the Delta IV Heavy, 1/3 the cost, factor of 6. Okay, but if you want to reduce it by a factor of 100, we need to increase the launch rate by a factor of 100. There's only about 100 satellite launches occur every year worldwide, and they were already gotten about 40% of that market, which is incredible. But they'll cheapen the cost, there'll be more satellites. So, okay, maybe we'll double or triple the number of satellites. That's still not enough to get us to $100 a pound to orbit. But while there's only 100 and maybe 200 or 300 satellite launches a year, there's thousands of intercontinental flights every day. And if you can take part of that market, then you can reduce the cost of space launch so that the cost of going to space will be comparable to a first-class ticket from Los Angeles to Sydney. Okay. So this thing has been unleashed, and it's, as I say, it's not just Musk. He has opened the door because people are saying if he can do it, I can do it. And that's not necessarily true. He's pretty good, but but nevertheless, there are other smart people in the world, and they will try, and that's the key thing. And then the other thing that's been shown, and this was something that I was not a leader in, but one of the people who was, Rick Tumlinson, is going to be here tonight giving a little talk, the new space revolution of doing things not by having the government do it itself, but contracting services from entrepreneurial organizations. I mean, look, Dragon, has been developed and flying in a tiny fraction of the time as Orion, which isn't even flying yet, and not to mention a tiny fraction of the cost. So this commercial off-the-shelf program that showed that you could deliver payloads to the space station, this is how we can do the moon and Mars. We don't have to wait for NASA to develop its giant interplanetary spaceship to depart from the interplanetary space station in a crazy orbit around the moon. You say, look, we want this much payload delivered to Mars and this much payload delivered back. How much do you charge for that? Okay, and then allocate contracts on that basis. On that basis, we can have a moon base within 4 years, a Mars base within 8, if we want to do that. Okay, and that's the kind of program that we need. So, I mean, look, the fundamental issue is this. The reason why the space astronomy and planetary robotic exploration programs have delivered and the human spaceflight program has not is because those are purpose-driven programs. The human spaceflight program has become a vendor-driven program. Purpose-driven program spends money to do things. A vendor-driven program does things in order to spend money. Okay, and that's the problem. Okay, it's nothing to do with the inherent difficulty of human spaceflight. Okay, I mean, look, what Musk did with first Falcon 1 and Falcon 9 was show that the problem of access to orbit was not fundamentally technological, it was organizational. Cost plus contracting, etc., creating no incentive to cut launch costs, creating no incentive to reusable vehicles. I mean, I once proposed a reusable vehicle to the management of Lockheed Martin when I was there, and they said, this is really smart, Bob, but if we build one of these and sell it to the Air Force, we're out of business. That was a bit hyperbolic, but that's how they did it. So the idea is to create a structure where the incentive for the contractors is not to do things as expensively as possible. At Martin, we used to say, at Martin Marietta, overhead is our most important project. Because you could charge 5% over on top of it. Now, but you create fixed price competitive contracting where it's the incentive to the contractor to cut costs to the bone because whatever is left after their cost is their profit. And that's how things need to be. But we need a purpose-driven human spaceflight program. The human spaceflight program needs a goal. That goal should be humans to Mars. It should be humans to Mars because Mars is where the science is, it's where the challenge is, it's where the future is. Okay? It's where the science is, it's where we can discover the truth about the potential prevalence and diversity of life in the universe. You can't do that on the moon, and certainly not in lunar orbit. Okay? Mars is where the challenge is, and challenge is important. Civilizations are like individuals. We grow when we challenge ourselves, we stagnate when we do not. A Humans to Mars program would be a tremendous bracing challenge to every country that participated in it, and a tremendous challenge to their youth in particular. It would say to every kid, learn your science, you can be a pioneer of new worlds. And out of that challenge, we get millions of scientists, engineers, inventors, technological entrepreneurs, doctors, medical researchers. Okay, intellectual capital is the basis of the wealth of a nation. Okay, you think you're going to get intellectual capital by testing the kids to death every week? Okay, which is what the educationalists are proposing? No, you want to further education, inspire the kids. That's the real program to do it. And finally, the future. Because if we do what we can do in our time, which is establish that first human foothold on Mars, okay, then 500 years from now, there will not only be several new branches of human civilization on Mars and perhaps thousands in the asteroids,